Yes, there is a similar provision in the National Electrical Code for alternating current generators that automatically start providing power locally during a power outage. National Electrical Code Article 702, which covers emergency and standby power systems, includes sections that address this issue. 702.5b states that when a generator set is used to supply power to a distribution system, automatic means shall be provided to disconnect the generator output from the distribution system upon loss of voltage on the normal source. 702.12 states that generator sets shall be provided with automatic transfer equipment to isolate the generator output from all other sources in a manner to prevent reverse power flow. These requirements ensure that if the grid voltage is lost, the alternating current generator will automatically disconnect from the distribution system to prevent any hazardous condition for someone trying to repair the grid. These provisions exist to safeguard personnel working on the electrical grid during outages. When a generator is supplying power to a facility, it's crucial to prevent power from backfeeding onto the de-energized grid. This backfeeding, or reverse power flow, can create a dangerous situation for line workers who may assume the grid is dead. The National Electrical Code addresses this hazard by mandating automatic disconnection and isolation of the generator from the distribution system. The automatic disconnection is typically achieved using an automatic transfer switch, often abbreviated as ATS. This switch monitors the voltage of the normal power source, which is usually the utility grid. If the ATS detects a loss of voltage or a significant voltage drop on the normal source, it automatically initiates a transfer sequence. Firstly, the ATS disconnects the load from the normal power source. Secondly, the ATS starts the generator. Thirdly, once the generator reaches its rated voltage and frequency, the ATS connects the generator to the load. The reverse process occurs when the normal power source is restored. Firstly, the ATS detects the restoration of voltage and stability on the normal source. Secondly, the ATS transfers the load back to the normal source. Thirdly, the ATS shuts down the generator after a cool-down period. This ensures a smooth and seamless transition between the generator and the grid. The isolation requirement mentioned in 702.12 is critical to prevent reverse power flow. This is typically achieved through the design and configuration of the automatic transfer switch. The ATS must be a break before make type switch, meaning that it breaks the connection to one source before making the connection to the other source. This prevents any possibility of the generator and the grid being connected simultaneously, which could lead to backfeeding. Furthermore, the ATS should be rated for the specific voltage, current, and frequency of the generator and the electrical system. It should also be listed and labeled by a recognized testing laboratory, such as Underwriters Laboratories, abbreviated as UL, to ensure it meets applicable safety standards. The National Electrical Code provides detailed requirements for the installation and wiring of emergency and standby power systems. These requirements cover various aspects, including the sizing of conductors, overcurrent protection, grounding, and wiring methods. It is important to consult the National Electrical Code and other applicable standards to ensure that the generator system is installed and operated safely in compliance with all applicable regulations. In addition to the National Electrical Code requirements, there may be local codes and regulations that apply to generator installations. It is essential to check with the local authorities to determine if any additional requirements exist. Some jurisdictions may require permits for generator installations and may have specific requirements for noise levels, emissions, and fuel storage. Regular maintenance of the generator and the automatic transfer switch is crucial for ensuring reliable operation. The generator should be inspected and tested regularly, following the manufacturer's recommendations. The automatic transfer switch should also be inspected and tested to verify that it is functioning properly. Maintenance tasks may include changing the oil and filters, inspecting the batteries, checking the wiring connections, and testing the transfer operation. Proper grounding of the generator and the electrical system is essential for safety. The grounding system should be designed to provide a low impedance path for fault currents, which helps to protect against electric shock and equipment damage. The National Electrical Code provides detailed requirements for grounding electrical systems, including generators. These requirements cover the size and type of grounding conductors, the grounding electrode system, and the bonding of metal enclosures. The sizing of the generator is another important consideration. The generator should be sized to provide sufficient power to meet the loads that will be connected to it during a power outage. It is important to consider the starting currents of motors and other inductive loads, as these can be significantly higher than the running currents. A properly sized generator will be able to handle these starting currents without experiencing excessive voltage drop or frequency fluctuations. Fuel storage is another critical aspect of generator installations. The fuel storage system should be designed and installed in accordance with applicable codes and regulations. The fuel tank should be located in a safe area away from potential ignition sources. The fuel line should be properly sized and protected against damage. The fuel should be stored in a way that prevents contamination and degradation. The generator should be equipped with appropriate safety features such as overspeed protection, overcurrent protection, and low oil shutdown. These features help to protect the generator from damage and prevent unsafe operating conditions. The overspeed protection system will shut down the generator if it exceeds its rated speed. The overcurrent protection system will trip a circuit breaker or fuse if the generator is overloaded. The low oil shutdown system will shut down the generator if the oil level drops below a safe level. In summary, National Electrical Code Article 702 provides important safety requirements for emergency and standby power systems. These requirements are designed to protect personnel and equipment from hazards associated with power outages and generator operation. By following these requirements, it is possible to ensure that generator systems are installed and operated safely and reliably. Firstly, ensure compliance with NEC Article 702. Secondly, install an automatic transfer switch. Thirdly, regularly maintain the generator and transfer switch. Fourthly, properly ground the system. Fifthly, size the generator appropriately. Sixthly, safely store fuel. Seventhly, incorporate safety features. These steps contribute to a safe and reliable emergency power system.